Okay, lesson 1.6, using precision and measurement. Precision is the level of detail an instrument can measure. So like on a ruler, you see how it has, you can measure by the foot, because an entire ruler is a foot, right? You can measure by inches, so that's a tighter precision, or you can measure by centimeters. That's an even smaller precision amount. Does that make sense? So that's what the word precision is talking about. If you look at these two watches, let me take a picture. Which one of these two watches has a more precise time?
Mia's.
Mia's. Why Mia's?
Because it has seconds and...
It gives you the times and stuff.
Exact.
It gives you down to the seconds. So hours, minutes, seconds. This one just gives you hours and minutes. Right? Now, do some of these types of watches have the seconds hand?
Yes.
Yeah, it's usually a tiny little red one like that going around, but in this case, this one didn't. So what you're going to be doing is choosing the more precise measurement for part of this lesson. So let's look at we're on page 35 in your books. So for each of these, you're going to choose the more precise measurement. So we have 7 centimeters and 7.3 centimeters. Which of these is more precise? Anybody else? He just ends at 0.3. Yes, this one gives you to the 10th, whereas this one's just the bigger number. So this is the more precise measurement. Yeah, the more details you get. Very good. For B, we have 5 yards or 16 feet. Which of those is more precise?
16.
Very good, because it's a smaller measurement. C, we have 1 pint or 16 ounces. 16 ounces is the more precise. Okay, I want to do some of the guided practice down at the bottom, so you're going to put these in the journal. I just want to practice them. Number 1 is 21.13 ounces versus 21.4 ounces. Which one is more precise?
21.13.
You guys agree?
Yes.
Yes, she's correct. For number 2, if I have 14 and 1/2 inches versus 2 and 5/8 inches, which one of those is more precise?
14.5.
Which one is bigger, the 1/2 or the 5/8? Which one is more parts? This is only out of 2, this is out of 8.
Oh.
So this is the more precise measurement. That's why we're doing this, it takes practice. All right, number 3 is 14 millimeters versus 2 centimeters. Which one is more precise?
2 centimeters.
14.
Millimeters is smaller than centimeters. In your centimeters on the ruler, the millimeters are the little lines in between the centimeters.
Yeah.
So this is the more precise measurement. And the last one, we have 2.5 hours versus 90 minutes. Which one is more precise? Yes. Here's the funny thing. They're going to give you some of these that are similar. Like if they had done this one where it was 1.5 hours, that's the exact same measurement. 1.5 is the same as 90 minutes, right? But still, the more precise one is the one that's down with the smaller measurement, even though they're the exact same amount of time.
Oh.
You see the difference?
Yeah.
We're discussing precision, not how much time has passed. All right. So now let's talk about significant digits. All right, significant digits is when you are measuring the digits. Let me start over. Significant digits are the digits in a measurement that carry meaning contributing to the precision of the measurement. So, long story short, a significant digit is a number that actually counts towards letting you know how big something is. So a lot of the times you'll see like a decimal, 2.100. Significant digits are the ones that actually count. Do these zeros really tell us anything new? No. So these would be the only significant digits. That make sense?
Yes.
All right. So write that key concept in your journals. I'm going to give you a minute to do that. So. All right, so let's talk about these significant digits. So here's the rules of thumb that you guys need to always look back to determine whether something is a significant digit. Any non-zero digits are considered significant. So in this first one, are there any zeros?
No.
So all 5 of those are considered significant digits. Okay? Zeros that are to the right of both the last non-zero digit and the decimal point. So you see how this has 2 zeros before the last non-zero number? They still count. Zeros that are to the right of both the last non-zero digit. I'm making sure I'm saying this right. So those 2 don't count. The last 2 are the only 2 that count, because that tells you to what place value we went to. And then any zeros that are between significant digits. So you see how we have a 5 here and a 7 here? The zeros between it count. This one we didn't have a number between it, right? It was started off with 0. So that's why this one is worth 4. Okay? So let's do example 2. Put this in your journals. So A is 290.01. How many significant digits are there? Definitely the 2, 9, and the 1. What about the zeros? Are they significant or not?
Yes.
Yes, why?
Numbers?
Yeah, they're between the 2 actual numbers. So how many significant digits are there?
5.
5. And I'll let you abbreviate.
Okay. Same thing.
Yep, I think it's funny, but it works. All right, 0.8500. All right, so definitely the 8 and the 5. What about the zeros? What about the first 0 on the left? Is it significant?
No.
No.
Because it's not a 2.
What about the 2 zeros after?
No.
No, actually they are.
No, they are.
Because they tell you to what level is precise. I think I wrote that wrong for you guys earlier. The ones beforehand are the non-significant ones. So this one has 4 significant digits. Okay, and then let's look at C. We have 4,000 miles. How many of those are significant? The 4. H, hold on.
No, they're all.
No, just the 4. So this is 1 significant digit. Okay, so really keep this key concept available. That way you can remind yourself of the rules. And it has the examples there, so it shows you what's significant and what's not. Okay? I accidentally turned. Okay, let's determine significant digits in calculations. So this is after you've done either multiplication, addition, subtraction, division. Then you have to determine what is significant. So during addition and subtraction, you're going to round the answer to the same place as the last significant digit of the least precise measurement, so the bigger measurement. So in this case, we have this one's to the hundredths and this one's to the tenths. Which one of those is more precise? Anthony? Which one of these 2 is more precise?
The 3.24.
Yes, so we're going to do it to the tenths because we were going to do it to the least precise one. Okay, so we're going to round it to 1 decimal place. Make sense? For multiplication and division, the product or quotient, the answer, must have the same number of significant digits as the least precise. So same thing. So on both of these, we have, let me erase this a little bit. We have the top one is how many significant digits? 1. And the bottom one has how many significant digits?
2.
So which one is the least precise? The 1 significant digit. So once we get our answer, we're going to round it to there's only 1 significant digit. So in order to get 1 significant digit, it's that last one. So we look at the 2. Does the 2 make the 1 go up or stay the same?
2 makes it go.
stay the same because it's below 5. So when you're rounding it, it just stays the same. So you're going to round it to 1,000. Okay?
Yes.
Any questions on that? All right, one more example. Let's look at example 3. I'm going to practice this. We're going to perform the indicated operation and then write it to the correct number of significant digits. So we have 45.1 plus 19.45. First of all, which one of these is least precise?
45.1.
45.1. So we're going to round our answer to the tenths, right? All right, so now let's add this. 5 plus 0 is 5. 4 plus 1 is 5. 9 plus 5 is
14.
4, 5, 6. Bring my decimal down. 64.55. So we're rounding it to how many decimal places? 1. So what does that 5 make this 5 do?
Go up.
Yep, so my answer is 64.6. You're fine. Actually, I'm going to write this one the other way. When you're doing multiplication and division, write the longer number on top because, just multiplication. Because then you only have to multiply it by 2 numbers. Or you could use your calculator. Okay, so which of these is more precise?
2.6.
Yeah, 2.15. And we're going to go to the least precise. So we're going to look at that 6.4. And we're going to round to, again, 1 decimal. Well, to 2 significant digits. So
6.40.
Well, we got to do the multiplication first.
Oh.
Then you round it to the least significant, which is 2 significant digits. Okay, so if you were to multiply this, I'm going to cheat because I already know the answer. You're going to get 13.76. But we're rounding to how many decimal places?
2.
No, we're rounding to 2 significant digits. I got to remember that. Sorry. So how many of these is 2 significant digits? The 1 and the 3, right?
Yes.
So we got to look at that 7. What is it making the 3 do?
4.
Yes, so the answer is 14. Good. Any questions on that? It's kind of a wonky assignment, I know. Numbers, this is lesson 1.6. You're going to do 3 through 35, just the odds. I keep bumping that.